good afternoon, everyone.
Good afternoon, sir. Good afternoon.
Yeah, thank you. I welcome you to another edition of our TQ webinar series. We're super elated and glad to have you join us this lovely afternoon or morning or evening, depending on wherever you are. My name is Olumide Aderinwale. I'm Operations Manager at TechQuest Academy. And today, as displayed on our various screens, if you're joining us on YouTube or on Zoom, you're welcome. Today, we'll be discussing data science in practice with our facilitator and TechQuest mentor, Dr. Ikenna Ivenso, who's excited, like I am. Before we proceed, kindly proceed to the chat section and introduce yourself. We would like to know your name, we'd like to know where you're joining from, and we'd also like to know what you hope to gain from this webinar. Please note that this session is being recorded, and attending the webinar means that you consent to being recorded as an attendee. Before we proceed to introduce Dr. Ivenso, let me just run through who we are as an organization, that is us at TechQuest. TechQuest STEM Academy is a STEM organization that provides education, technology, content, resources, and tools for the delivery of ICT, digital literacy, and STEM programs for young Africans at scale. We believe STEM is the foundation for modern-day economic growth, and equipping young people with these skills will be critical for Africa's rise in the digital economy. That's a summation of what we do at TechQuest. So because the time is short, let me just quickly run through Dr. Ikenna Ivenso's profile, and then we'll hand over the session to Dr. Ikenna to take over. So Dr. Ikenna is a senior principal data scientist. He's a data scientist, software engineer, and computational biophysicist. He's currently a senior principal data scientist at Dell EMC, Austin, Texas, in the US, where he leads the implementation of data science initiatives for global deployment and partner services. He was the senior design automation software engineer at Intel Corporation, where we worked with the advanced design group, leveraging historical, experimental, and simulation data to develop software tools for automating the design and development of microchips. Dr. Ivenso holds a PhD in mechanical engineering in computational biophysics from Texas Tech University in the United States. Can you please join me as we welcome Dr. Ikenna, our facilitator from this webinar. We're glad to have you. Hi.
All right. So I'm glad to be here, and thank you very much for that introduction, Olumide. It's going to be a very short session, and it's going to be more of an overview. I'm not going to go in depth into any topic. With that said, let's get started. Let me share my screen here. And please, if you mute your mic so it doesn't distract everyone.
Okay. Please.
Right. Thank you. So let me know when you can see my screen.
We can see your screen.
Okay, can anyone not see my screen? I guess we're all good then.
If you can't see your screen, could you please just drop a message in the chat section, either you're on YouTube or on Zoom? I guess we can all see your screen now.
Happens. So let's get right into it. What we're going to be doing today is talking about data science in practice. What happens in when we deploy data science or when we employ data science in a business setting, more or less. And what I'm going to be doing is talking about what data science is, and then we're going to talk about what data is, where data comes from and all that. Then I'll go through an example of a simple data science project. So basically the life cycle of the project, how does it get started? How does it proceed to its logical conclusion? Then I want to spend some time talking about machine learning because that's a topic I've gotten a lot of questions around. And there's a lot of excitement around it. And there's also a lot of misconceptions around that. So I'd like to spend some time talking about that. Then at the end, I'm going to spend some time talking about two questions I get asked often around the data science career. How do I become a data scientist, and how, or more importantly, I guess, how do I get a job in data science? All right, so let me go ahead and. So we've gone through the introductions already, and Lumide has already put us through that. So thank you again for that introduction, Lumide.
It's a pleasure.
So data science, what is data science? So there's several definitions, around what data science is, but there's three key things that happen with data science, or three key elements here. We have the data, we have the tools, and we have the insights. So data science uses various tools to extract insights from data. That is what it primarily does. And those tools include maths and statistics, algorithms, experimentation, visualization, any tool you can think of that would help derive insights from data. So think of data science as a toolbox, basically. So a good data scientist should have a diverse set of tools in that toolbox. And think of data as the workpiece, what you're trying to get something out of. And insights is the outcome of the eventual what you get out of data. So those are the three key elements of data science. You have your data, you have the tools you have to work on the data, and you have the insight to extract from the data. I wanted to, there's some definitions of data science that kind of mention the fact that data science drives value. But I want to point something out, that value is something further down the line. If you get your insights and you don't act on them, you're not going to get any value out of it. So that's a key distinction between data science as a profession and what you get out of it, basically. So let's look at some use cases in data science. Where is it used? How is it used? These are just a few of them. Several possible use cases. So look at the aviation industry. We have airlines that have saved over the years, saved hundreds of millions of dollars by using data science in their scheduling to reduce aircraft downtime. And the big online marketing platform, Amazon, generates about 35% of its total revenue, as of today, from its recommendation engine, which is driven by data science. Then look at the finance industry. Banks have saved billions of dollars by using data science to prevent cybercrime, to prevent fraud and stuff like that. Data science has a huge application in healthcare. Two of the many use cases is in patient electronic health record management, and using data science to build tools to analyze medical images. Think of your X-ray images where you have a virtual doctor, trying to determine whether there's a tumor in that X-ray image or not. Then in advertising, the data science drives targeted advertising. So if you're an advertiser, you want to make sure that your campaigns are reaching the right people and that you get the right outcome. You're trying to get the people to the people that are most likely to convert to customers. So data science helps drive that as well. Now we've talked about data science, but then what is data? Where does data come from? So in very simple terms, data is anything we can observe or measure, and basically helps us. Having data helps us make better decisions. So let's use a very simple example. Let's say you have a friend, whose birthday is coming up, and you're thinking of what to get that friend for his or her birthday. If you don't have any data around what your friend might like, or more, maybe what they already have in the, like say you're trying to get your friend a shoe. If they already have a lot of shoes, that might be a bad decision you're making. And if they do need a shoe, but you don't know your friend's shoe size, that's data you're missing, that you could have used to make a good decision. So data empowers us to make better decisions. That's the point I'm trying to make here. And decision making improves, if we can store, retrieve, and analyze data. So basically, when we have that data readily available to us, we can make better decisions faster. So an example of that is it's okay, it's easy to remember, all of your siblings' birthdays. But if you're the manager of a big group, of a huge team, and you're trying to remember all of your subordinates' birthdays, that might be a challenge if you don't have it saved somewhere that you can retrieve it easily, or there's something that sends a notification when the birthdays come up. So that's one of the ways that being able to access data readily helps us make better decisions. So where does data come from? There's all sorts of data sources. We can talk about a few of them here. We have data from social media, your Facebook, Twitter, Instagram, LinkedIn, and the rest of them. There's lots of other social media platforms coming up today that's generating a lot more data. Excuse me. You have data generated from industrial machinery, data that logs operating conditions, sensor outputs, or even computer networks, the efficient, how computer networks are operating. We have data that comes from transactions, from online payments, receipts, inventory, all sorts of transactions. We have data that comes from the government, right? Census data, election data, GDP data, stuff like that. And something I wanted to talk about non-traditional data sources. There's a lot of data that lies dormant because they don't come in the traditional form, and we don't generate value from those because a lot of people, frankly, don't know what to do with it, or maybe have the skills to generate value out of it. And I think it's easier for me to show you than to tell you. So I have an example here. On the left, I have a screenshot from a WhatsApp group that I belong to. It's a group that has about 150 people. And, we interact in all sorts of ways. We send messages to each other. We celebrate each other's birthdays, our achievements, and all that. So sometimes I want to figure out, hey, on what days do people interact the most? On what days do we have the most posts? So what I did is to export that data and analyze it in some ways. And on the right here, the top right figure shows me that Fridays are the most active days. So that makes sense. People are getting ready for the weekend. They don't have meetings or work anymore, so they have more time to interact. Then I also wondered what time of the day, in my time zone, are people most active? Because people in this group live everywhere around the world. So I wanted to figure out what time of the day are they most active, and the chart on the bottom, tells me that they're most active around between 9 a.m. and around 2 p.m. my time. So it gives me a kind of a distribution of the activity level on that group over a long over the time period that I analyzed. So this is one way we can use a non-traditional data source, and there's so many of them out there. We have books, we have you have the the website, we have newspapers, we have call and chat history, we have address books in your phone books and address books. So let me pause here for some questions. Does anybody have any question so far? Is there any question coming in yet?
If you have questions or you seek clarifications, could you please just proceed to the chat section, either on Zoom or on YouTube, and drop your questions, okay? And we'll attend to them in due time. Not yet, Dr. Ivenso.
Not yet. Okay. All right, then let's go on then. If you have questions, I'll be happy to go back to whichever section you have a question about and give you any clarifications you might need. So let's spend some time talking about machine learning. Let me move this around a bit just so I see. Okay, so Machine learning is a very hot topic these days, and there's a lot of value to be derived from it. There's also a lot of misconceptions that people have around it. So in talking about machine learning, there's also a lot of other terms that are around it that cause a lot of confusion. So I wanted to give in this slide, I want to give a hierarchy of where machine learning is in the space of artificial intelligence. So I'm going to start by talking about artificial intelligence, or AI, as it's popularly known now in everywhere, especially in the movies. So AI is the artificial intelligence is the ability of systems to receive information, to analyze that information, and to carry out some action based on that input, based on that information. So an example would be a car collision the collision avoidance system to have in modern cars these days. And the car can sense when objects are close by. It can sense how fast it's moving and how soon it might collide with that object. And the action it takes is to start braking to avoid that collision. So that's one example of AI. So basically, there are three elements here. It receives information, it analyzes that information, and it carries out an action based on that information. And all of these steps are called, are lumped into one called reasoning. So basically, an AI is able to reason almost like a human being. But unlike a human being, most AI that exists today are good at only one task. So that's called narrow AI. And what a lot of researchers, what a lot of people in the tech industry are working towards today is what's called general AI, where the AI can do a lot of things that a human being can do, not just be good at one thing. Now, machine learning is a subset of AI. If you look at the figure here on the right, machine learning is embedded within AI. And machine learning uses AI to learn from experience without being explicitly programmed. What does that mean? So basically, machine learning, what sets it apart is that it uses data it uses historical data that's been generated in the past and learns from that data on how to respond, how to act in the future. So that's what sets machine learning apart. So think of your recommendation engine. If you go to your Amazon profile and you make a certain kind of purchase, if there's a pattern to that purchase, you probably get recommendations on similar things in the future. Or think of your spam detectors, your email spam detectors. It's looked at emails that you've labeled as spam in the past, and based on that, it learns to recognize new emails that come in and classify them as spam or not spam. Now there's deep learning, which is gaining a lot of traction these days. And deep learning is a subset of machine learning itself. And deep learning is the concept behind deep learning is that it's supposed to mimic the human brain by representing information in several different abstract levels. So think of the image of a person. If you ask a very good artist to draw a person, they probably draw a very good portrait. If you ask a less skilled artist, they probably draw something less accurate or less or not as good as a seasoned artist. Now, if you keep doing that and get down to a child, a 4 or 5 year old, they're probably going to draw you a stick figure. So this is the same information being conceptualized at different abstract levels. So that's how deep learning works. Every layer in the network takes the information and expresses it in a deeper level of abstraction. So think of your image classifiers. Those are things that tell you whether the image is a cat or a dog. Or think of your Google Assistant or your Siri that is able to recognize your voice. So those are applications of deep learning. I expect that people will have questions now, but let me get this slide out of the way first. Again, I have to move this thing around. Okay, so what is machine learning good for? Where is it useful? So I want to differentiate. I want to point out the difference between machine learning and your conventional programming. So in your conventional programming, you have your data, for example, and you have some rules governing the output, what happens to that data. You plug all that into your conventional program, and what you get is your output is going to be answers, what the outcome is So the conventional programming takes your data and your rules that are programmed into it and gives you the output. And on the other hand, machine learning, what it does is it takes your data, your historical data, and it takes the historical outcomes from that data, and it's able to figure out the rules. So that's the fundamental difference between machine learning and your conventional programming. Again, this is something that's easier to show you than to tell you. So I'm going to use two examples here. So look at the, let me turn on my laser pointer here. Can you guys see my laser pointer? The red dot here. Okay. Okay,
yeah,
cool.
Yeah,
okay.
yeah.
All right, so those of you that have an engineering background, especially electrical engineering, would recognize this thing right away. This table. This is the truth table for an OR gate, or So basically, what it does is it has two inputs and one output. If both of the inputs are off, then the output is off. If any of the inputs is on, then the output is on. So that's how this works. Now the rule is very simple and straightforward. So we don't need machine learning for here for this example. So here we have our data, the two inputs. We have our rules that say when any of the inputs is on, the output is on. Otherwise, the output is off. Those are the rules. Now with that, we can get our answers very easily. So if somebody just gave you these two inputs and told you this is an OR table and told you the rules, you can figure out these answers without building any kind of machine learning model. Now let's look at the table on the right, to the right of that. This is when I did the GRE, I think it's much different today, but when I did the GRE, the maximum score for quantitative and verbal was 800. And the writing was, I think it was scored over 6, over 7. I can't remember now, but basically different engineering schools have different criteria for admitting people based on that. So this is an example of a table from an engineering school. I made this up anyway, but it's very similar to what they do. And we have the score. Each line, each entry here represents a particular candidate that applied for admission. And what they do is that they look at these two scores, your three scores actually, your quantitative, verbal, and writing scores, and make a decision on whether to admit you or not. Now we don't know. I mean, I know, but because I did it, but it's not immediately obvious what the criteria that govern this admission process. So in this case, we might need machine learning. So if we have enough of this data and we have enough of the outputs, we should be able to figure out the rules behind how people get admitted to this particular engineering school. So in summary, machine learning is useful when the rules are not obvious or when they are too difficult to code. So sometimes you might know the rules, but it's just too difficult to encode it. So you look for historical data and figure out a model-based rule for that. And what kind of problem is a good candidate for machine learning? If a reasonable amount of data exists and there's some pattern that exists in that data, and the pattern follows this thing, it follows this rule here, where the rules are not obvious or too difficult to code, then that is a good candidate for machine learning. So this is how you determine whether your use case is a candidate for machine learning or not. So I'm pretty sure there'll be questions by now. So let me pause for questions here. Has any question come in yet?
Yes, we have a few questions now.
Okay.
The first question a couple of people asked was how you generated data from WhatsApp, how you exported the data, right? When you wanted to analyze the most active time for the people in the WhatsApp group.
Okay. Yeah, I wasn't expecting that question, but yeah. There's a on I use an Android phone. I don't know if it's the same for other platforms like iPhone and all that, but when you go to the group, there's when you go to your group, there's an option to export the data. So that's what I did. It's actually a simple, straightforward process. The hard part was actually on doing the analysis. Does that answer your question?
Yes, I believe it does. Another question is this: what's the most used machine learning model in practice? This is from Moses Igbo on Zoom.
The most used, that would depend on the problem. So every problem has its peculiarities, and there's a model, there's one or more models that are most suitable for that problem. So a better way to put that question would be, what is the most common problem in machine learning? If you know that, then you would know the most used model. But I would say I don't know, and I don't think there is one. I think every model gets tested for every problem, and whichever model works the best is used. So generally, when you're trying to solve a problem, you try different machine learning models and see which one works best.
Okay, thank you. Another interesting question from Kelvin is, must you be a software developer before you become a data scientist?
No, that's a categorical no. In my career, I've met data scientists from the social sciences, people that did sociology, political science. I've met data scientists, that came from astrology, astrophysics. I've met data scientists that came from technical language writing. These guys are the ones that become experts in natural language processing. I've met data scientists from core engineering, of course. I've met data scientists from computer science, but they come from all over the place. So you don't have to be a software developer. But it helps if you can write some code, definitely.
Okay, awesome. There's a question from Dotto on Zoom. How is business analytics related to machine learning?
Business analytics, as far as to the extent that I've encountered it, is basically taking data from the business and charting trends. Basically discovering trends in the data. They don't necessarily do any machine learning. I haven't seen any business analytics team that does machine learning to do any kind of reporting. So business analytics is primarily I may be wrong on this, but in all of my time working in data science, I haven't encountered that. So I think there are two separate things. So machine learning, I would say, is a tool in that data science toolbox. It's one of the many tools in the data science toolbox.
Okay, awesome. Thank you. There's a question from Alex Pimu. Pardon me if I didn't get that right. Asking what the difference is between doing machine learning with Python and R.
The difference will be in the syntax. Like if you're using R, you have to read it. Your code is going to be different from what it will be in Python, but they will be equivalent if you're solving the same problem. So you can solve the same problem in several different languages, but I personally prefer Python because for two reasons. It has a very well-developed code base. It has a very well-developed, a very, very active community. So there's a lot of modules out there that have been developed for their data science in Python. I'm sure it's the same for R, but I think Python has a lot more activity going on in the data science space than R does. But I think it will be best if you actually have a grasp of both of them so that you're not handicapped when it comes to the advantages of one over the other.
Okay, awesome. Thank you. There's a question from Florence on Zoom asking what the best entry point for professionals in social sciences is into data science.
Now, this is just my opinion, but I think the entry point is defined by the problem you decide to go out and solve. That's how most people get into data science anyway. They decide that, okay, well, there's this set of problems that I'm interested in solving. So if you're a social scientist and your interest is in population statistics, I don't know if that's the correct term, statistics that, have to do with a demographics, a demographic or, stuff like that. That may be the problem you're trying to solve, and that will be your entry point into data science. If you realize that you need some data science tools to solve that problem, definitely go for it. Don't let that limit you. The fact that you haven't seen someone that looks like you or has your background in that field shouldn't be something that limits you.
Okay, awesome. Thank you. There's a question from Chita on YouTube asking how you plotted those graphs, how you represented the data from the after exporting on WhatsApp.
Okay, I think that problem is getting a lot of interest. I'll be happy to do another webinar just for that. But I did all of it in Python. So once I exported the data to a text file, a TXT file, and imported that into Python, and everything else I did was in Python. So cleaning up the data, matching it up to make sure that everything makes sense, all of that was done in Python.
Okay, thank you. There's a question from Victor. Victor says he's interested in operations management and is asking how data science will profit him or be useful to him.
I think there's a lot of use cases for data science and operations management, where you're trying to optimize a business process or stuff, stuff like that. But I would say that data science has a lot of application in a lot of fields. So it doesn't really matter what field you're going into. If you find a use case for data science, go ahead and apply it and get insights from, get value from, drive value from that. But for operations management specifically, for Victor's addressing Victor's question, I don't know any use case off the top of my head apart from the ones that I just mentioned, but I'm sure I can assure you that there's so many of them out there, so many use cases.
Okay, there's a question from Cynthia on Zoom. Cynthia is asking, is advanced knowledge of data science a major prerequisite for bioinformatics?
Bioinformatics. I don't think you need to know better data science to do bioinformatics. I mean, I took a lot of bioinformatics courses in school, and I didn't have to do any data science for that. Well, we did have to analyze data. We did have to get data from DNA and all that and analyze it, but we didn't do any machine learning. That's what I'm trying to say. I don't know if that was what you were getting at, Esther, but bioinformatics is the field that definitely will benefit from data science, but data science is not a prerequisite, as far as I know, to get into data. Data science is not a prerequisite to get into bioinformatics, as far as I know. And I know this because I did a lot of bioinformatics myself.
Okay, awesome. Thank you, Doctor. There's a question from Antonia on YouTube. So you were talking earlier about having a reasonable amount of data. Can you please talk a bit more on that?
Okay. Sometimes it's not easy to tell beforehand how much data you need. Of course, there isn't such a thing as too much data. But you can, when you started to solve a problem and you find out that you're not seeing the patterns you expect to see. One of the primary causes of that is that you don't have enough data for your model to learn from. It could also be that your model doesn't have enough skill to learn from that amount of data, because there are some models that that require less data than others. But generally speaking, you know that you need more data if your model is having trouble learning from the data you have at hand. That's one way to know, to figure out that you need more data.
Awesome, thank you, Doctor. There are two questions about career opportunities from Samsudin and Lami, so I'll just combine both of them.
Okay, so I'll take those questions, and we move ahead just for the interest of in the interest of time.
Okay, awesome. So Samsudin asks what career opportunities you think are available in Nigeria for data scientists, and Lami asks how you identify and choose a career between being a data scientist and a data analyst.
Okay. Let me. I'm going to ask you guys to be a bit patient, because I addressed that at the end of this presentation. So I think let's keep those questions for that part of the presentation. It will make much more sense then. Is that okay?
Okay, that's fine.
All right. Okay. Yeah. Let's move on with I want to talk about the life cycle of a data science project. So this is just a simple idealized life cycle. Usually, some projects, some projects actually have more items or more steps than this, and some of the steps actually, there's some back and forth between every, some pairs of steps. But this is an idealized life cycle. So the first step here is defining your problem. So this is the step where you define the scope, you scope out the problem, and you articulate the nature of the problem. And this can't be overemphasized. This is a very critical step, because if you make a mistake here, everything else you do here is gonna be tainted by that mistake you made at the beginning. I mean, you don't want to get to the end of the process and realize that you weren't answering the correct question in the first place. So the definition step is the most critical one. This is where you define the nature and scope of the problem. And when you've done that, the next step is to collect the data you need to answer those questions that you've just articulated, right? So you want to make sure that the data that data exists, that it's complete, and that it's relevant to the question you're trying to solve. So if you're trying to find out if the stock market is going to go up or down, you don't get data on Arsenal's performance for the past 6 years. It doesn't give you any information, so that's not relevant data. The next step is to prepare the data to make sure that the data is tractable for what in the way that you can use your computer to solve it, to answer the question you're trying to solve, to solve the problem you're trying to solve. So in this step, you clean the data, you explore it to make sure that there is no outliers, and you transform the data where there's transformation needed. Then in the next step, this is where you do your modeling. This is where machine learning comes in. So this is where you identify what kind of machine learning model you're going to use to train train your model and to evaluate the performance of that model. So in this step, the part about evaluation is something that's very critical, because what you're trying to do is to make sure that when your model sees new data, it can predict it very efficiently. So that's why evaluation is a very important step here. Then when you've done all of that, when you've built the model and evaluated it and it's working well, you can deploy it. So this is where your stakeholders are, you deploy your data, your model in the way that your stakeholders can use it. And sometimes maybe your stakeholders don't need you to deploy the model. Maybe they just need insights one time, a one-off, kind of insight. So the next step is to communicate the results to your stakeholders. Okay, so let me show some examples of each of these steps. So the definition step. Let's see how we're doing on time. Okay, I think we're good on time. So when you're trying to when your task is to articulate and formulate the problem, some of the skills you're going to need is some domain knowledge. Domain knowledge means that you have some knowledge about the domain that your problem exists in. So if you're trying to get some insights from some data about the last elections, you want to make sure that you have some knowledge about how elections are conducted and how the data is collected and all that. So some of the things you have to do in this step, you have to ask the stakeholder what questions they want you to answer. You have to take whatever they tell you and formulate it in a way that question can be answered with data. You have to find out from the stakeholder what outcomes they're hoping for, what the insights they're hoping for will look like to them. You want to find out from the stakeholder how they operate their business. So the processes that generate this data, what are those processes? And how do they measure the success? So how would you have to know from the get-go how you figure how you can tell if your model is working well or if you've answered the question to their satisfaction. So I have in the red box, I have an example of a business example of a use case from a telecoms company. So the business side of the company, they spend a lot of money on targeted advertising and promotions and other activities aimed at customer retention. So they're trying to keep their customers with these advertising. And they would like to know beforehand which customers are likely to churn, which ones are likely to cancel their subscriptions. They will also like to know what causes people to cancel their subscription. And if they know all of this, it will enable them to save money on the activities they do around customer retention by targeting specific customers. And they could also be able to reach customers that are likely to churn before they do churn. And they gave two specifications here. They're not particularly concerned about false negatives. So if my model is going to classify someone as not churning when that person will actually in fact churn, they're actually concerned about that, but they're not as concerned as they are about false positives, which is where customers are classified as churning when they will not in fact churn. So this is what I got from this fictitious business here. These are some of the things that you would ask or you will get from a business to answer the questions. Then when you have all of that, let me move this around. The next task you have is to identify what data you need to answer these questions. So the skills you might need for this step, will be, you have to definitely have to have access to the data, and you need to have the skills to get the data from wherever it's stored or wherever it is. So sometimes the data might be in a text file or an Excel file, which is okay because a lot of us, are good at Excel and all that. But if it's stored in some database, you have to have some database, some ability, in handling or retrieving data from databases. So some of the things you have to ask, or some of the things you need to do, you want to know if there's data, if the data is available, and if there's enough of it, if it's, if there's a reasonable amount of that data. Now you want to know if that data is accessible. Are there some bottlenecks to accessing that data? You want to know if the data is relevant. Is it the data you really need to answer this question? Is it complete? Does it represent? Is it representative of the problem, or is it imbalanced? So these are some of the things you ask in this step. Now, the next step is to prepare the data. So at this point, you should have your question already articulated, and you should have your data. You should have access to the data you need to answer the question. So now you need to manipulate the data to explore it, to see if the data is structured or unstructured. So structured data is basically data that exists in an organized format, like in a table. Or structured data, is the opposite of that. Doesn't exist in it exists maybe in a semi-organized format or in a totally unorganized format. And you need to know what fields exist in the data. So if, for example, you're looking at the problem I just defined in the first step, you want to know how much time the customer spends on every month on calls. You want to know how often they've called the customer care in the past month or the past year in some time period. These are some of the things you want to know. So you want to know if those fields exist in the data. Now you want to know if there's outliers. So if you're looking at, say, customer age, for example, and one customer says they're 250 years old, it's either somebody just playing around, or maybe maybe it's just a typo. Maybe they meant to type 25 and they put a 0 at the end of it. So this will stand out as an outlier. You want to know if there are strong correlations between any of the fields in the data. So for example, if you have call duration, a field called call duration, and you have a field called the charge for that call, you can tell that there's going to be some correlation, because the longer your call goes on for, the more you're going to be charged for that call, depending on what kind of package you're on. And you want to know what data types exist in each field. So some fields will be categorical data, like customer name or customer location or stuff like that, or customer phone number. Some fields will be numerical data, like customer age and stuff, and stuff like that. Some fields will be like booleans, where it has a true or false kind of entry there. So these are some of the fields that can exist in your data. You have to know what fields, what types of data exist in each field and where they are. And you also want to try to see if there are new features or fields that can be engineered from the existing fields. So if I were to give you my date of birth, you should be able to take that date. You should be able to take that date and subtract it from the current date and tell my age. So if I give you my date of birth as one of the fields, you should be able to develop a new field that's my age and stuff like that. So these are some of the things you do in this step. Now, when you've done all of that, it's time to select and build your model. Now, this is another critical task, because every problem has a type of a machine learning model that's suitable for it. So for this step, you're going to need to have a lot of machine learning knowledge and skills. And some of the questions you're going to ask, or some of the things you're going to need to do, you want to know what kind of technique best suits the problem. Is it a question? Is the problem one that is asking me whether something is a yes or no? Is the person going to churn or not? Yes or no? Or is it asking me in how many days is this person going to churn? So now you're trying to predict a continuous number. So you need to know what technique suits each of those questions. You want to know if the data needs to be further transformed. So if you have a categorical data, you might need to encode it. So data that says location of the customer. So we have 36 states in Nigeria, right? You might want to create a field for each of those states so that the data exists in a numerical format that the computer can use. Now, when you're choosing a model, you want to know what kind of insight you are trying to generate in the first place. So you're going to need to choose a model that can be easily explained if necessary. So, for example, in the recent past, a year or two ago, the Facebook CEO, Mark Zuckerberg, was called before the Senate to testify, and he was asked to explain some of the algorithms that go behind their newsfeed on Facebook. And he had a hard time explaining it. And that was probably because the model wasn't that easy to explain. So sometimes if you kind of envisage that you're going to have that kind of problem, you want to choose, or you want to be partial towards a technique that's more easy to explain, that's easier to explain. Then this is just a word of caution here. Choose the most stable technique. Don't just choose the coolest one or newest one. A lot of times I see people that that just say they want to use deep learning for everything just because deep learning is in vogue right now. Every single problem they want to solve, they want to use deep learning. That's not a very good way to approach problems. Then always test and evaluate the performance of your model. One simple way that that everybody, a lot of people use is they separate their data into. They break out their data into a testing set and a training set. So they use some part of the data to train the model. Then they use the second part of the data to test the model. So they're pretending like, oh, the test set is something that the model hasn't seen or trained on. So basically, that's how they figure out how the model is going to perform on new data. So these are some of the steps we need for this. Then the last two steps I'm going to combine because they're basically the same thing. Sometimes you might need to deploy the model. Sometimes all the stakeholder needs is that you give them insights. So for this task, we're going to need one of the things we're going to need the most is communication skills. So if you've done all of this cool work and then you're unable to communicate it to the stakeholders, it might seem very obvious to you, but they're not going to derive any value if they don't understand what you've done or how they can use it. So this is the key skill that you need in this step. So some of the things you need to do is to understand your target audience. Which if you're looking at stakeholders, is most likely people at the executive level. These people might not have any expertise in data science, and they want you to explain things in their own terms, in a way, in terms that they understand. So for this, we need to avoid the temptation to use a data science jargon, communicate to them in their own language, and be sure that you've addressed the problem that they are concerned about, the problem that they they tasked you to solve in the first place. This is something I've seen a lot of times. People go in there trying to explain how complicated their model was and how much time they spent on it, and forget to address the problem that they're trying to solve. So this is a key skill. So I've said a lot there in a short time. So let's see if there's any questions yet.
Thank you, Dr. Ivenso. There are a couple of questions that we've curated since the last time we took questions.
Okay.
Yeah. There's a question from Dotun on Zoom. Dotun asks, what part of data science is most applicable to business process reengineering?
Business process reengineering.
Yeah.
So basically, you're trying to make your business process more efficient. I don't think there's any one answer to that question. You would have to figure out what kind of inefficiency you have in your business process in the first place. So, for example, some of the problems I deal with, sometimes customers order things and they don't get to them on time. We want to find out why this thing is happening. Sometimes, it gets to the customer, but it's damaged. We want to see if there's a pattern to that, that occurrence. So there's no one kind of machine learning model that's applicable to, that's a magic bullet that's a silver bullet for business process reengineering. It depends on the specific problems you have in your business and why you need to make it more efficient. When you've defined that problem, then you can figure out the best model for that. So it goes back to what I said in the life cycle. The first thing you need to do is to figure out specific, to articulate the problem very clearly. Then when you've done that, the rest of it is easier.
Okay, awesome. Thank you, Doctor. There's a follow-up question to Chita's former question, or now you exported your data. So Chita asks, you said you translated the text file to Python. Is there a tool that generates it to graph from Python?
Yes, there's a plotting tool in Python. Python has a visualization tools that you can use. So basically, I took the data, put it in transformed it, and put my output in a table. Then I was able to plot my charts from that table.
Okay, awesome. Thank you, Doctor. There's a question we didn't address the last time. That was career opportunities you think are available in Nigeria for data scientists.
In Nigeria, okay. I think there's a lot of opportunity. I mean, Nigeria, right now, has a lot of opportunity for applying data science to make our process more efficient. And we're basically very fertile land right now. So there's opportunity in the banking sector, there's opportunity in the telecom sectors. There's opportunity in small and medium scale business, definitely. We can do much better in how we collect taxes and how we put our tax money to use. We can, there's opportunities that exist there. So I think what we need to do as, especially all of us on this call, would be to start to look at these problems and figure out which ones we want to solve. And I guess that's one of the reasons for this webinar, to kind of stimulate that, to get those discussions started, and to stimulate that interest. Okay. So to answer Cheta's question, there's a lot of opportunities out there, and they're just there waiting to be explored. So don't be looking for opportunities that people are already working on. Try to look for new opportunities where you can generate a lot of value.
Okay, thanks, Doctor. Samuel on Zoom asks, can data science help in examining the quality of data collected? So, for example, you do regular data collection. Can data science help in examining the quality, setting some rules?
Yes, and that depends on what you mean, and it depends on who you ask. But when you talk about data quality, there's a lot of definitions for that. So data quality could mean that the data is not complete. It could mean that the data is, complete but wrong. It could also mean that the data is there, but you can't do anything with it. So there's a lot of possibilities in that, but you can definitely use data science to. So let me give an example here. There was a time I was working on a natural language processing model where I needed text data. So basically, I was working on surveys where customers give us feedback on our services, basically. And I was looking at the text of those surveys, and I realized that in a lot of cases, the text was truncated. So depending on where the tool came in, where the survey came in from, it might be that the tool that was collecting that survey was truncating it at a certain character, after a certain number of characters. And I wouldn't have been able to find that out if I didn't apply some analytics to the data collection itself. So that's one example where data science can help in improving the quality of your data.
Awesome. Thanks, Doctor. There's a question from Ike, I believe from Zoom, I should believe. Is there an estimated time or period for one who is a beginner in data science at the moment to become a professional and be able to have a career in it?
It depends on what you mean by professional. I mean, if you're trying to be the CEO, it might take you longer than it would, for you to get your first full-time data science role. But one thing about this field is that you get from it what you put into it. That's definitely true all the time. So two people that start at the same time might not get to the same role, at the same time, at the same, they might not peak at the same time. Let me put it that way. Even if they take exactly the same path. So because what one person, what the motivation one person has might not be the same level as the other person's motivation. So it depends a lot on what you put into it.
Okay, thanks, Doctor. There's a question from Ridwan Sani on Zoom. Is data analysis different from data analytics?
Data analysis is what you do when you're doing data analytics, right? So data analytics is basically one way of trying to generate insights from data. And data analysis is one way of doing that. Unless by data analysis you mean what the question I just answered earlier, if you're trying to analyze the data itself, like where the data comes from and if the data has any quality. But generally speaking, data analysis is just one of the steps in data analytics.
Okay, thanks, Doctor. There's a question from Florence here on Zoom. Kindly explain the application of this.
Before you go on, we're already almost on time. Is it okay if we go a bit over time? I still have a few, 2 or 3 more slides to go through. Does anybody object very strongly to that?
Could you please plead with everyone? Would extend the webinar by a few more minutes. Kindly.
Okay.
Yeah, that's fine.
Okay. All right. So yes, please, the question again.
Okay, so Florence asks on Zoom, kindly explain the application of data science on agricultural forecasting and traceability in agriculture to make it relevant in production management. Pardon me.
Okay. I mean, there's a lot of use cases that of data science in agriculture. You have your supply chain, so moving your produce from the farm to the market. You have your weather forecasting. You want to know what the weather is going to be like, if it's going to be beneficial to the crops, stuff like that. I think she specifically mentioned production management.
Yes, she did.
I'm not sure what that means, but if I'm assuming maybe you mean how well your crop is going to do in a specific season. Is that correct? Is that what you mean, Florence?
Florence, please clarify that. While we wait for our clarification,
Okay.
There's a question from Daniel on Zoom. Daniel asks, can you please recommend credible places where one can take a data science course and be fully ready for the job?
Okay. This is somewhere that a lot of people get confused. Because there's a lot of material out there. There's a lot of courses out there, and they don't know which one is the best to take. My suggestion is to start small. And by that, I mean identify where your gaps are. So if you already have a degree in computer engineering, for example, you may not need to, or if you're already very good in coding, you may not need to go start learning Python from scratch again or learning R from scratch. So the first thing to do is to identify your gaps. Then seek out material to bridge, to fill in those gaps, in your knowledge. And of course, practice. These are things I address in the last part of the presentation anyway.
Okay, thanks, Doctor. There's a question from Omotayo. She's asking clarifications around the application of data science in education.
Interpretation of data science in education? Application of data science in education.
Yeah.
I mean, there's all sorts of things. A lot of school districts, for example, try to measure educational outcomes, and they collect a lot of data around that, and they need to make sense of that data. So they want to measure student performance, student learning outcomes, teacher performance, and stuff like that. they want to make sure that some of the programs that they implement, that they fund, if those programs are being effective. So these are some of the applications of data science in education. Okay, yeah, Olumide, let's stop there for now and go, get the rest of the presentation out of the way. Then we can have more time for questions at the end.
Okay, awesome. That's fine. Thank you.
All right. So let's talk about some of the frequently asked questions I get all the time. The first one is how do I become a data scientist? And I think some of the questions I already answered have to do with that. So how does one become a data scientist? There's all sorts of advice you're probably going to get, but I think speaking from my own experience and my personal experience of learning, and people have mentored or taught data science, one thing that sets them apart is that they have a deep curiosity and strong passion for data science. This is what's going to keep you going if you come against the obstacles or if you're in data science just because you think it's cool or it's the next big thing. You might not last very long if you face some obstacles. So your deep curiosity and your strong passion are what are the things that are going to keep you going. Then it helps to take advantage of of every available resource, and most of them are free. These days, there's a lot of online resources free. There's a lot of blogs from data scientists that talk about their own journey and everything. Then it's good to start small, identify your gaps, and practice consistently. Always practice to fill in those gaps. And when you've done that, when you filled in a certain gap, identify the next one, and that's how you keep growing. Then good data scientists, people that learn the fastest, are the ones that seek out new challenges. So they don't just constrain themselves to one domain. When they've mastered that domain, they keep looking for new challenges. So this is one way to improve, and this is one way to build out your toolbox. Then it helps to keep up with the data science community, and this is because data science is a field that's changing very fast. There's all sorts of new advances that come out every day, so it helps to keep up, with the community. One way to do that is to find a data scientist or you kind of want to follow, to basically learn from. And, follow them on social media. Some of them have Twitter handles, some of them have Facebook pages or LinkedIn, some of them have blogs. So find out what they're doing and what new things they've worked on and all that. Then this cannot be overemphasized. Keep learning. The worst kind of data scientist is the one that gets cocky and thinks they know everything. You can never know everything because there's always new things and there's always new approaches, even to the same old problems. So you need to keep learning. It's a lifelong learning process. Then one way to retain the stuff that you've learned is to teach others. So this helps to reinforce your learnings. When you transfer that learning to others, it helps you to reinforce that, or it helps you to reinforce that learning, to internalize it. So these are some of the things that are sure to help you towards your journey to becoming a data scientist. Now, the next question I get is, how do I get a job in data science? And for this, my answers are going to be short because there's no silver bullet, but these are things that are going to help you. To get a job, what you're trying to do is to impress an employer, right? You're trying to get someone to be interested enough in you or to see enough value in you to employ you, right? So one thing that helps is to build your online, to build a portfolio, whether it's online or whatever way you do it, mostly online, like in places like GitHub. So when you've worked on something, put it out there. Don't just keep it to yourself. Put it out there and let someone know that you've solved the problem that they might be interested in. And another thing is to work on interesting problems, interesting or challenging problems. So a lot of the questions I answered, just a few minutes ago, have to do with around use cases in agriculture, in education, in business process, reengineering, and all that. These are challenges that people face in the industry, and some people are already frustrated at this point. They don't know how to solve those challenges. So if they get an inkling that you have been thinking about the same problem, the same way, the same problem that they have, and you might actually have a solution to give them, they're definitely going to be interested in you and want to employ you. Then one thing that helps a lot is to build out your data science toolbox. So I always encourage people to think of data science as a toolbox. So as you grow, you add more tools to that toolbox. that makes you more, it makes you more valuable to an employer if you have several different ways to solve several different types of problems that, both the problems they have currently and problems they might encounter in the future. Then the last key thing is to master effective communication and storytelling. So you're probably going to be working with stakeholders who are not, the kind of expert, you don't have the kind of expertise in data science that you have. And you need to make sure that you communicate the insights that you have to them. If the insights are not communicated to the people that are going to deploy them, then those insights are useless. It's just something it might as well be a hobby. So effective communication helps to communicate those insights to the stakeholders that people are that need the insights and are going to implement them. And storytelling is a way to keep their interest, basically, to basically get them interested in the insight you're providing and to keep that interest. So these are some of the things. We're like 7 minutes over time. So let me take the last few set of questions and we'll call it a day for now.
Okay, thanks, Doctor. Let me go through a few. There's a question from Abdul Samad on Zoom, I presume. What's the difference between the use of Python or R and softwares like SPSS or API info in data analysis?
To be honest, I haven't used SPSS specifically. I used it a long time ago, but it was just for very simple data analysis. It was so long ago, I don't even remember what I did with it. But Python and R are two different tools that can achieve the same thing. Python, in my humble opinion, is much more flexible because it has a lot more people working on it. It has a lot more community support. And it also helps that Python is free. It's free software you can install. So I'm personally partial to Python, but that's just me. That's just my personal opinion. People, develop different preferences. So Python is my personal preference.
Okay, thanks, Doctor. Can you please provide some impact and some insight into what big data means?
What big data means? Okay,
Yeah.
big data, that's a term. I probably should have addressed that in this presentation. Big data is something that you hear a lot about these days. And what is big data? There are three things that there are three key attributes that make something big data. You have the volume, the three V's: the volume, the velocity, and the variety, I guess. So the volume just means how big the data is, how much of it there is. Then velocity means how fast it's coming at you, how fast is that data coming. And variety means in what kind of formats, does that data come in? What different kinds of formats that the data come in? So think of Google, for example. Google has billions of searches every day. And when they log that data, that's big data because there's a lot of things that people search about. They search about careers, they search about their health, they search for the nearest, maybe the nearest barber or the nearest doctor. Then search is coming. Google can search for images, they can search for text, you can search for, on shopping sites and all that. So that's where the variety comes in. So I think that qualifies it as good as big data. It has a volume, it has variety, and it has a velocity. There's a lot of searches that I think there's millions of searches per second, if I'm not mistaken. So yeah, I think those are the three key things that make that set big data apart: the variety, the volume, and the velocity.
Okay, thanks, Doctor. Florence has now clarified her question. So she says, thank you, Dr. Ikenna. I'm asking how best we can use data science to trace agricultural produce through the value chain.
To trace agricultural produce to the value chain. Okay.
Yeah.
So basically, not just to increase the yield, but to also increase revenue, I guess. At the end of the day, that's the value, right? If you have yield, but you sell it for cheap, they're making that much revenue. So, Like, so I would answer it, with respect to, making reference to the life cycle I referenced earlier in the presentation. So you first need to identify the question you want to answer. So you want to know, maybe you want to know, okay, is there some value to cutting out the middleman so that I can sell directly to the market and make more money for myself? Or, should I keep the middleman? Is there some value that the middleman provides for me that I might not be able to get otherwise? So those are some of the questions you might want to answer. So definitely, if you frame that question correctly, data science can definitely help you answer that question. And I don't know if that answers the question, Florence.
Yeah, I believe it does. There's a question from Daniel Akakabuta. Pardon me if I got the pronunciation wrong. I'm on Zoom. Can you quickly highlight things that must be on a data science resume to best present yourself to employers?
Okay, so let's imagine that I want to hire somebody. So different employers are looking for different things. If I'm trying to hire someone, I want to be sure that they are problem solvers, that they're able to articulate a problem and solve it correctly. They're able to, if they make a mistake, that they're able to correct it, identify the mistake by themselves. They're basically creative. They have initiative. Different people look for different things, but these are things that I would, as an employer, look for. And these are things that I've looked for when I've interviewed people. Some of the skills that I listed here are things you can actually learn on the job. But if you're someone that doesn't take initiative, or that you don't, you're not inquisitive, you don't ask the right questions, you probably wouldn't do very well on my team. So if I were to put out a job description, I would make these things very clear. So any good job description should make the requirements very clear, what they want to acquire. And one thing you need to do is when you are trying to get a job, you want to do some research on the company, because sometimes they might talk up the role. They might make it look like a company is doing great things when they're really not. They're looking for their first data scientist to leave them, kind of bootstrap them. So you want to be sure that if that's not what you want, then you want to be sure that that's not what's happening with that job description. So getting a job goes both ways. Yeah, they're going to interview you and see what skills you have to fill that role, and you're going to be sure you want to make sure that this is exactly the kind of role that you want. So that's what I mean when I say that data science interview goes both ways.
Okay, thanks, Doctor. There's a question from Monica on YouTube. Please provide a guide in automating daily reports from Excel, especially using functions such as VLOOKUP, sum, and percentages. Just a quick guide.
Okay. I'm not an advanced Excel expert. Most of the things I can do in Excel, I can do it in Python as well. So it depends on where the data is coming from. So for example, sometimes I work with a database that gets updated every hour. So I kind of automate my script to pull data from it every hour, and make sure that it's only pulling data that's been updated recently and not the entire data. It saves time if you're only pulling new data and not pulling the entire thing all over again. So that's that's one way that I automate my data science pipeline. Of course, for that, you need to have some knowledge of how the database works. And if you don't already have that, it's easy to pick up. These are things you can look up on the internet and practice for yourself until you master it.
Okay, thanks, Doctor.
But for the Excel, I can't answer that question because I'm not primarily an Excel expert, so I'm not able to address that aspect of the question.
Okay, thanks, Doctor. We noticed a couple of questions that were previously answered are currently being repeated. So the recording of this webinar will still be on our YouTube channel,
Okay.
TechQuest Academy. So you can just proceed to watch that as soon as the webinar is over. We'll also provide additional details. The slides and additional resources will be provided on our website on Monday. So that's in 2 days. So you can look out for those. I think we can wind down the webinar. What do you think, Dr. Ivenso? Do you still want to take some more questions?
Are there more questions, and are people willing to stay a few more minutes? I don't think we're like 15 minutes over time, but Yeah. If people are willing to, I'm happy to take a few more questions if people are willing to stay. But if you really need to leave, then that's fine too.
Okay, thank you, Doctor. There's a question from Akko Amota. Akko asks, is there a ready-to-use, not so cumbersome way to record our population and lead us to actual elections in a true electronic and hard-to-rig system using data science?
One way to do that, and this is just something that I've thought of in the past. I haven't actually implemented, but one way to do that is to get population data from different sources and kind of use them as a way to validate each other. So you could get population data from census, but you could also get it from tax data, from tax records or from health records and stuff like that, and use it to calculate. So sometimes one way that people carry out fraud, and I assume that Akko is talking about the elections in the U.S. because I think that's where he lives. So one way that people kind of carry out fraud in elections is when they use the identity of someone who's already deceased to vote or to do other things. Now, if we have data from health records or from registry of births and deaths, whatever the equivalent is in the US, we can actually use that as a check and balance to make sure that whoever is voting. But then that would require significant investment. So if we have a government that is very concerned about electoral malpractice, they might want to implement that. If not, otherwise they might not see it as a priority. So that's my 2 cents on that.
Okay, thanks, Doctor. There's a question from Raya. Raya asks, is data science a good option for analyzing geospatial data?
Yeah, definitely. It's been used a lot. So, for example, people use satellite images to identify houses from surrounding landscape.
Yeah.
And use that as a way for to see how well the town planning initiatives are going. It's been done before. People use data from nighttime sky. So basically, think of when you're looking at the Earth from space at night, and you see some locations that are well lit up and some other locations that are not as well lit up. You can tell how much electrification has gone into a place. So, for example, big cities are going to have a lot of lighting, while smaller rural areas are going to have more sparse lighting. You can tell the population and the degree to which electric power generation is effective in certain areas from that data. So to answer your question, yes, data science has a lot of applications in geospatial analysis.
Okay, thanks, Doctor. There's a question from from Lin Song. Lin Song says he or she has an online learning business and is wondering how we can apply data science to online learning.
Okay, I don't know what kind of problems you have in your. I mean, I'm guessing you have problems like maybe competition. You have maybe in that space that you're operating, you have some competition, or you want to be sure that the learning outcomes are your transfer of knowledge is effective. You want to measure the learning outcome. Again, once you've formulated the question very articulate, once you've articulated the question, it shouldn't be too hard to find how to use data science to answer it if it's applicable. So if I'm telling you any specific use case, I'm just guessing because I don't know what problem you're trying to solve, but I can tell you that yes, if you pose the question in a way that you can use data science to answer it, then you definitely can find a use case there.
Okay, thank you so much, Doctor. Yes, just to reiterate, I said the slides will be shared. Additional resources will be provided on our website, so you can keep an eye on those for by Monday. Yeah, that's in 2 days' time to track those on the website. Let's take one final question.
Okay.
Can you please there's a question from an iPhone. Okay, what role does machine learning play in fraud detection?
What role does machine learning play in fraud detection?
Yes.
It plays many roles. One use case, for example, is in credit card fraud, where people use other people's credit card to buy things. Machine learning will be able to learn the patterns of legitimate use and to flag any anomaly when such a an anomaly. So sometimes, for example, when I spend, on one of my cards, one of my credit cards, I spend, I have a spending limit. I kind of use it for certain kind of spending. So it doesn't I've never bought any item over a certain price. So when I use that card to buy something else in another place that's over that limit that I usually use it for, I get an email or a call right away that tells me, hey, are you the one, is this card, do you have possession of this card, or did it get stolen and all that? And I have to confirm that I'm actually the one making that purchase. So that's one application of machine learning, for fraud detection.
Okay, Doctor. Before we go, we'll just provide some insights on the mentorship. That's the Data Science Bootcamp. And if you want additional details, you would also be able to access those on our website on Monday. Our website is tqstem.org. So the selection criteria. Interested participants will receive project exercises to solve using Python or any other programming language. And you just want to access your programmatic and algorithmic problem-solving skills, right? The top 10 best entries will be shortlisted, and those will be the people that would be admitted into the bootcamp. An email will be sent to every attendee, every registrant. If you join this webinar without registering for the event, please proceed to our Eventbrite profile, right? The link would also be provided in the chat section, both on YouTube and Zoom for you. Okay, so kindly register so that we can contact you and give you these details. So at the end of the 6 weeks, we'll do, the participants would be provided with real-world projects to do. So details of the assignments, as I said earlier, will be up on our website, that's tqstem.org, on Monday, and on our social media channels. So please subscribe, subscribe, and follow our pages to keep updated. So you can follow us on Twitter, Facebook, Instagram at TechQuest Camp, or just do a quick search for TechQuest STEM Academy on YouTube and on LinkedIn. So please subscribe to our YouTube channel, follow us on YouTube, follow us on social media and everything. To sponsor and support our programs, please visit tqstem.org.donate. We would love to have
I think we lost Olemi there.
On behalf of the TechQuest team and every webinar attendee, I want to say thank you so much to Dr. Ivenso for taking the
You're welcome.
time out to give us this lovely afternoon or morning or evening, wherever you are. Thank you so much. And to everyone that attended the webinar today, thank you so much. The webinar can still be replayed on YouTube, and then we'll send you an email with the direct link to access those. Thanks everyone for your time, and a special thank you to you, Dr. Ikenna Ivenso. Thank you so much.
You're welcome. Welcome. Thank you everyone for joining, and it was nice to meet all of you. And,
yeah.
I hope to hear more from you guys soon.
All right. Bye everyone.
Thank you so much, sir.
You're welcome. You're welcome, everyone.
Thank you, Dr. Ikenna, for the webinar. Much appreciated.
You're welcome.
Webinar.